Hi there. So this lesson, 2.4, was really mostly about finding the incenter of a triangle, but also this inscribed circle, the circle that fits right inside that triangle. And notice that in this diagram, see when I move this around, that circle is always right. We say that it's inscribed in the triangle. Um, and that we found the incenter already, but I'll remind you, it's the place where the three angle bisectors of a triangle meet. It's the concurrent point where they meet. Okay, so we've done these constructions in an earlier lesson, but each of these three lines cuts those angles into two congruent angles. But what I want to show you how to do today is how to actually make the circle that fits inside the triangle. I'm also going to point out that if you're in my class and you're doing these constructions in GeoGebra and the lessons that I've prepared, I've started installing these tutorials. And so a tutorial like this would show up in your assignment. Notice that there's this slider here, and this will walk you through every single step you need to do to make the inscribed circle like that. And you can move these blue points, but mostly all the instructions are there. And I want to also just kind of describe this circle for you for a moment. So you might remember that these angle bisectors, every point on an angle bisector is the same distance from each of the two sides of the angle. But because there's three angle bisectors, the incenter is the one place, the only place that's the same distance from all three sides at the same time. Okay, so that's where this diagram comes from. And yet, you got to remember that this distance is measured along perpendicular lines. You don't measure a distance to a line at some different angle. You always measure it as a straight shot at like 90 degrees. So that's another key to doing this construction, is you really just have to make a perpendicular line. Okay, so what I'm going to do in a moment is I'm going to do this set of things that you'll see, but this orange point is the point that I'm looking for, because it's the point that is a straight shot from the incenter to that side along a perpendicular line. So let's do the construction now. So here I've created a triangle and I found the incenter. I have my three angle bisectors showing. So what I'm going to do is, and you can feel free to adjust the corners of the triangle at any time if it makes it easier. I kind of like flat lines. So I'm going to start. I'm actually going to do something that I haven't done in class yet. And I found that this actually will make the construction more robust so that it can't disappear. So I'm actually going to first extend this side AB, the side that I'm aiming for. And the reason that I'm going to do that is because as I adjust the size of the triangle, the circle that I'm about to draw will also change. And I don't want to make it so that that circle can never disappear. So what I'm going to do when I make this circle is, because I want to find 2 points that are the same distance from the incenter, but I'm going to click outside this triangle out here. So see this point E, how it's light blue? Well, that point is attached to this line. So I can't move it off of that line. I can move it back and forth to whatever degree I like, and the circle will adjust in size. So maybe I want it to be right here. That seems pretty good to me. But the idea is that that point is always attached to that line. Okay, so I'm going to do that, and then I'm going to mark the place with my intersect tool. I'm going to mark the place where the circle hits the line. Oh, it's not going to let me do it. Okay, maybe I use my point tool. Well, let me do that. Okay, there we go. So there's point H, and let's just make sure if I move point E, how point H, yeah, see that stays on the line as well. All right, so, but the idea is that I can move those points outside of the triangle and the circle is still there. Now, let's finish this construction. Points E and H are both the same distance from the incenter. The incenter is kind of right in the middle. So all I have to do to finish this is create a perpendicular bisector of that smaller segment EH. So I'll click on E and I'll go to point H, and then I'll do the overlapping circle from H back to E. And then I'm going to use my line tool and I'm going to try to connect the two places where those circles intersect. And see what I made there is a perpendicular bisector of this segment EH. But what's really important is that it's a perpendicular line, right? So it goes from the incenter to this side and it makes a 90-degree angle. And that is the key. Let's just make sure I go this. Oh my gosh, look at that, 90 degrees. Perfect. Okay. So, and I marked the place where let me hide some things so we can see it a little bit better. So, oops. Wrong one, Mr. Alexander. There we go. Hide that, hide that. I'm going to hide that circle. Okay, so the line is intersecting the side of the triangle right here at a 90-degree angle. Okay, and so that is the key. This distance is the same in all three directions. So now I'm going to hide that line since I've already found my point of intersection. That's the important part. I'm going to make that point orange so it matches my diagram. Make it bigger. Okay, and then yeah, so then let's just make that inscribed circle. Let's make sure it works. So if I make this circle, there we go, and there it is, right? It's connecting here, it's connecting at this point, and it's connecting at this point. And if I adjust the corners of the triangle, there's nothing that I can do to make that circle disappear. There's nothing that we can do to make it, it's always inscribed within the triangle. It's always attached to the three sides. Follow the tutorial when you do this, and come to class on Monday or Tuesday ready to do it again. Have a good weekend.